Hi there, this is Karen Greenhouse again with some mini math lessons. So this is sort of a continuation of one we did before with counting candy, and we're going to go now into the total of the bag. So again, the free activity, the URL is in the description. Post it into your browser and the activity should pop up. Create a free ClassPad.net account if you want to save what you do, modify the activity, anything like that. Or you can just work with it as is. So what we have here is an activity, again, kind of a continuation of one that we did before. So in the one we did before, they counted the colors in a bag and kind of came up with a percentage. So now we're actually going to compare many bags. So this is a great activity to do if you are, say, distance learning and each student that you're with has their own bag, and then you compile all their data. Or you could have, say, it's Easter right now, you could get one of those bags with the small mini bags and use all of them. So count how many are in each mini bag and see if there's a consistency. So my data is using 20 different bags of 1.69 ounce M&Ms, and so they can use my data, or it's a lot more fun if they collect their own data. But so here's the sample data. So there's 20 bags, and each bag we've put the total number of M&Ms that are in the bag. So color's not what's important here. It's more what's the expected number in a bag of 1.69 ounces. The bags are actually filled by weight. So does that mean we get the same number in every bag? And if not, why not? Those types of things. And what can you estimate is going to be the number in a bag based on our data. So here's all the numbers that I collected, and if they're going to collect their own, whatever kind of bags, Skittles, jelly beans, whatever, they can record theirs here if they do that, or if you do this as a class. And so the first thing they're going to do is actually find some of the statistics. Now, they could calculate these. If you want them to do that, you could get out the calculator tool and actually have them add everything up and find the mean and count the which one has the most appearing, the mode. Or you could, since that's not really where we're going with this, we're going into statistical displays, is let the ClassPad do the work for you. So it tells them how to do this. So we're going to select the column, and there is this statistical menu that comes up, and we first want to do a calculation. So instead of doing it by hand, we're going to let the calculator do it, and we're going to use one variable. And so when I do that, what happens is I get the statistics for this data, so the number of M&Ms in a bag. So you'll see there's a lot of statistics. The ones we care about right now are the mean. So the mean is 53.2. There's a total of 20 bags. That's what N represents. The smallest number that I got was 48. The highest number was 58, so there's a 10 M&M difference there. I have my quartiles here, so I have my medians 52. So if I look at my mean 53.2 and median 52.5, it really is kind of 53. So right now I'm thinking 53 might be a good estimate for what I would expect in a bag, right? And then if I look at the mode, the one that occurred the most is 52, pretty close to 53. So 53 might be a really good estimate for what's in a bag. So then we're going to start exploring statistical displays. So the next thing they're going to be doing is, okay, so let's look at some of the statistical plots and how do those help us kind of make some determinations. So we're going to be doing a dot plot, a histogram, and finally a box and whisker. And again, we're going to let the ClassPad.net do the work for us. So they're going to be selecting their plot again, and we're going to hit the back thing, and there's now these graph menus. And the nice thing is you can do all the graphs on one. So let's first do a dot plot. So they're going to do the dot plot, and they're going to talk about what do these dots represent. So if they look at the numbers, there is one at 48. And then this is on 49, and so there are two at 49. So we can kind of quickly see, much easier than in the table, how many we have of each and which one had the most. So that'd be 52, hence that matches our mode. So we kind of get a kind of a feeling of how this is spread out. We can see the range. We go from 48 to 58. So a lot of things you can see with the dot plot. Then they're going to go back, select that same column, and do a histogram. And here's the histogram. It looks very similar to the dot plot, except, what's going on here. And this is one of the things you can change in a histogram is right now it's kind of averaged out. So I'm going to say I want each bar to just represent one number, and I want to start at 48. So notice what happens when I do that. It kind of matches the dot plot a little bit better. So here, if I look at the bar, I'm seeing at 48 I have 1. At 49 I have 2. I don't have any at 50. I have 3 at 50. So it's just a little visual, so you can change that and play around with that. So then the last plot we're going to do, or they're going to do rather, is the box and whisker. And this is a different kind of plot, right? Because if you look at it, what numbers are showing up here? And if they're not sure, they can go back up to their statistics. But here's the min, 48. Here's the max, 58. And here's our median, right? 52.5, the exact middle, almost 53. And so we can kind of get a little better sense of things. So then their question is, as they explore these different representations, which one do they think represents the data the best, and explain why. So they're going to be talking about that. And then once they're kind of going through that, then we're going to finally end up with, okay, what happens if you change the data? So if I change the data, so here's the, and we're going to use just the M&M, and they can go back and do their own, but here's the, my histogram and a box plot. And so they're told, try to add some numbers in here. So maybe add an extreme number. So let's add in, maybe it was an anomaly bag and it had 65, right? What happens to my plots if I do that? And so you'll notice by adding in that, I didn't hit enter. By adding in that extreme, ooh, my box plot looks kind of strange. And this extreme number's out here, and that's called an outlier. And if you look at this, it says identify outliners. If I ignore the outlier, my box plot changes back to the way it was, right? So we're going to ignore it, or we're going to not count it as an outlier. We're going to include it, and it changes my box plot even more. So they can talk about extreme values. Should we count them? Should we not count them? What does that do over here in my histogram? Notice it's sitting out here all by itself. So that's interesting. So then what if I just add more of similar values? So let's say, 52 and 45. So they're just going to explore what happens if I add more values, if I add extreme values, and kind of get a sense of what's going on with our plots, and how does a single value impact my median and my mode and my range and all those types of things. So fun explorations, and quick and easy to do because you're in a dynamic math tool that lets you change things quickly and then go back to the way they were before. So this is a fun activity for them to explore and to collect their own data if they want to use their own candy or use the one that's there. So have fun with that.